I'll have a short introduction about myself. I'll do first an introduction to platform engineering, and then as a possible solution, how to use Crossplane, and then some demo. I will be more focused on application use, developer use cases than infrastructure use case. So unfortunately, no demo about how to use Crossplane to provision virtual machines, as Temo just teased, but I'll have other use cases presenting for you. I co-founded Vision based in Zurich and Vancouver, Canada 10 years ago. And we've been organizing this meetup since 2016. Do I have it on a slide? No, I don't have it on a slide. Basically, me and Tober, our CTO, we went to the Cloud Native to KubeCon in Berlin. And we thought, that's an awesome topic. Let's organize something. And we've been using this technology stack for to operate applications, both custom applications for software developers, agencies, and software service companies, as well as for software product vendors that want to make their product into an online service. And of course, over 10 years, there's more and more products we've developed that, of course, products for platform engineering, products for writing stuff on Kubernetes, that, of course, is interesting for other DevOps teams and platform engineering teams. And we of course started that because 10 years ago, I was in my 30s. I thought, or just after my 20s, where I thought like, yeah, this kind of firefighting in operations is super awesome. And actually some of our company, we have 3 people in our company, I think, that are still like firefighters in their local communities. So I guess there's some pattern here, right? But starting to go in my 30s, I was like, yeah, this reactive stuff, that's not fun anymore, right? It somehow feels not sustainable. And actually, only a few years later, I was doing a presentation for a group of IT auditors, and I was looking at, okay, what is this IT governance stuff? And I found this model here. And of course, I found myself perfectly in the, which is a model for like, a generic model for like process maturity, can be used for any process. But in IT operations, I guess I found myself down here in the initial ad hoc chaotic bucket, right? I think that's where IT operations were in 2014. And of course, the question is, how do we get to this higher level of process maturity where, of course, the risk gets minimal and the productivity quality gets maximal? How do we get there? Well, the solution is actually in the picture. Automation, right? If you automate all the repetitive, boring tasks away, we have more time to work on optimizing the process, as it says over there. And of course, that helps to become better over time. And that's exactly what our industry didn't do 10 years ago, right? We had the big gap between development and operations, or development and infrastructure. And of course, none of them talked each other's languages. I studied computer science at ETH Zurich. I was more in the dev part, and I was like, what is this hardware stuff, right? And hardware people are like, these developers, they don't know what they're doing, and it's always crashing, and I'm kind of, waking up in the night trying to fix it, right? And just about 10 years ago, we figured out that, as an industry, it makes sense to kind of work together, to combine the two forces, to use similar tooling, similar processes, development, thinking about, okay, how to make this like horizontally scalable, highly available, infrastructure people starting to automate stuff, starting doing stuff, infrastructure in code, putting that in a Git repo, making it versionable, making it testable. So these are kind of learning from each other, stuff that, for example, software developers have been doing since the 80s, 90s, right? Depending on where you're from. And it emerged, kind of like this cell division, right? It emerged as kind of specialty that is somewhere in between development and infrastructure, right? Between development and hardware. And I call it the operations part, right? It's the DevOps movement where we found out that, okay, it's kind of generic, too generic for many developers to really focus into it, but it's too specific for infrastructure people to go help the single developers, right? So they're kind of being able to focus on the generic stuff, the generic software stuff, not the hardware. That's something that I think we found out as an industry, or some of us are still finding out, right? And I think what's happening now in the past year and a half, 2 years, is that there's kind of this additional layer coming in between that we call platform, right? It's about the offering not hardware services, but offering software service as a service, with like 24/7 support and whatever, that then DevOps teams can use to help their developers to make their software into an online service, right? So it's kind of this specializing and sub-specializing that I think is more often shows how we as an industry mature than only adding complexity. And of course, all of these have different needs, right? Developers want to push change, push innovations, push features, and traditionally, infrastructure people want to have security, stability, which means as little change as possible. And of course, in between is the buffer zone that can enable that. So giving ease of use, self-service, and speed to developers by giving them power, by giving them tools, and by giving them the abstractions so that it's safe for them to use that self-service, right? And to make, even though they're doing it quickly in speed, they're not doing something, or it's limited what they can do wrong, right? So how do they work together? Well, as with all software problems, it probably makes sense for them to work directly together using an interface, right? Kind of an API. And just as, development and DevOps have been working together in, software CI/CD pipelines and automating that kind of build and deployment away from each other, and DevOps being as mainstream as it can get. I've been doing now the DevOps survey in Switzerland for the 8th time, and I guess we're like at 89-point-something% that are actually already using DevOps. So actually, we're not going to ask the question, are you doing DevOps next year anymore? Because everybody's doing it, right? Have to find new questions for next year. If you want to have more information about the state of DevOps in Switzerland, it's a report free of charge, of course. But still, it's a question of choosing your battles, right? If you have a DevOps team working like software development end-to-end, where do you put your agile team of 10 to 12 to max 15 people? How do you distribute them, right? Do you put them all into one bucket of doing software development, software operations, and the infrastructure operations, where you kind of have one person per yellow box, right? And well, you won't get that much speed into application development, right? Or can you outsource some of your problems, whether it's infrastructure or even platform, so that you have your 12 people working on the application, maybe on the data stuff, right? And all the rest you can use as a service provided by a platform engineering team, right? And I guess that's the splitting the DevOps and the platform engineering. And I want to motivate you to think about what are these kind of services and what are you kind of specializing on that you can develop and provide to other DevOps teams that are running their software end-to-end. There's a lot of open source tooling we already know, and actually a few of them we already heard, and I heard some earlier before we started even talking to them. And of course, all of these are open source, free to use. They're even like commercially supported versions of those. And one of the services that I want to mention specifically is the orchestrating external services, which is a tool called Crossplane, which is part of the CNCF. And of course, that's the tooling that you can use to enable this self-service so that the software developers can choose to do what they do. And I'm going to illustrate that on something we do. We use the Vision Application Catalog, AppCat for short, which is an open source tool that we then use to provide this kind of standard services as a service to our customer or even our internal customers, like our internal DevOps teams. And that's the documentation that's running for that. And now, how does this Crossplane work and why does that work, right? So let me make a very brief example, right? So you can, in Crossplane, enables you as a user to give a very short you have a very small interface, right? As an application developer, I can go and I can order a Postgres database with 7 lines of YAML code, which is very short, even though the stuff Teemu showed earlier was a lot longer, right? So it's an abstraction, so it's easier for the software developers to use it, giving them some or the permissions that you think make sense without letting them shooting in the foot, while still giving them the ways to do it themselves, right? You don't have to call you to make a Postgres database in this case. And then you as a developer get back, in this case, a secret You can say what the name of the secret should be, and then it gives you back the secret, which has the, of course, base64 encoded. Here is decoded. For example, here the host name, the username, the password, and SSL certificate, so that your application can then use the Kubernetes secret to access the database and do whatever database stuff you want to do, right? So that's an example of giving this abstracted interface from the platform team to the DevOps team so that they can do their databases, whatever they want to do, without giving them, making them either do their database themselves or having to call you to make a database for them, right? I mentioned there's an API, and you show the minimal API that we've implemented for our use cases. We have a long list of kind of options that you can set or just leave away, and then it takes some sensible defaults. And of course, that's kind of the beauty, right? There's a sensible default, but then as a user, if you need more control over when the backup is done or whatever, we can expose that and we can make sure to sanity check that before actually applying it to the production data, right? So for example, if somebody disables the backup or if somebody kind of says, hey, this is super important SLA guaranteed availability service, but I only want one replica, that's a stupid idea, right? So then we give an error message. You're not allowed to do a high SLA, but only single replica service because we think that's stupid. Don't do that. And we say no, right? And this kind of business logic we can implement in this API. And we use Crossplane for that. Crossplane is a CNCF project, incubating, I think. Don't think they've graduated yet. They have been in the process for, I don't know, many months. Let's see how long it takes for them to graduate, which is basically a set of Kubernetes operators that are running on your cluster. That's directly from the website. The idea is that you can declare your API, your interface that you want to offer to your users, your customers, your developers, and then you have the open source tooling enabling it to make sure that it works, to make sure that there's like a standard interface they can use to major cloud providers or infrastructure or whatever. And your definition of your interface is, open source in the sense of it uses open source tooling. It's an open standard that you can use with Crossplane. You could, of course, use it with any other solution as well, but it's not something that you have to, do specifically for a specific cloud provider or specifically for your on-prem infrastructure. You can use the same Crossplane on any infrastructure. And that, of course, makes it much easier if you have more than one infrastructure to make an interface that can work on any infrastructure, right? So for a developer, I order a Postgres, and I don't care if I'm running on AWS or Azure or on-prem. It makes me a Postgres that makes sense on that infrastructure, and gives me back the Postgres, and whether that runs on-prem or bare metal or is actually a cloud service in the background, I don't have to care. And that's the beauty why I like this open standard approach to be able to do that. It has a lot of stars and a lot of contributions. I guess the main point of this slide is to show you, yes, there's a shit ton of Kubernetes operators on GitHub. Most of them are developed by a person in their basement, like myself. But this is a bigger project, right? The chances this project is going haywire or is abandoned or archived is pretty slim because, just as with Kubit actually, there's a few companies investing in it, and that helps this open standard not only to grow, but also to be maintained in the future. So how can I use that? How can I do that? So for example, if I want to be able to offer this kind of API where I can say I want a NoSQL database, I want to be able to give it a name, and I want to give able to give like this parameter of location into it, which is one of the minimal examples I can do. This is the YAML code that basically describes this schema, right? So as a platform developer, I write this, I load this into my Kubernetes cluster, and from then on, Kubernetes knows that, if somebody comes along and says, I want this kind of NoSQL, then I can pick it up and then I can sanity check it, of course. For example, I want to give it a spec with properties, and it has to be a string, and it can be exactly one of EU or US, and if it's something else, I say no, right? So that's a way to configure Crossplane or to describe your API that you want to provide to your users. And of course, this you then put in your Git repo and you apply it with Argo CD, and then you have your GitOps pipeline, of course, also for your API that you provide to your customers. And then you make a second object, like, okay, this is the definition of what you can do or are allowed to do. And then you have the second object, okay, so what do I do with that, right? So in this case, I want to make an S3 bucket. As you can see here, name S3 bucket, right? And then I take the parameter of location and I put it into the, if it's EU, I use EU North 1, and if it's US, I use US East 2. And then I provision, in this case, a DynamoDB on AWS, again, using the region. And again, I put the region into the DynamoDB object that I use for AWS. So as you can see, this example is for AWS. It's for AWS only, but going back one slide, I didn't have to know that it's actually running on AWS, right? You can abstract it away for your customer. And as you can see, it's already like 2 slides and not readable, and I'm sorry about that. It's going to be on the test later on, I'm joking. So if you have more, let's say, complex templates, right? You can do it in YAML, or there are actually Golang bindings that you can define all this in code, and then you have the whole power of Golang with like sanity checking it and checking it in and building it and all of that. So that's actually the way we do it for our product. So that's a screenshot from our product, Vision, github.com/vision/appcat, that of course is open source, so it's free to use, right? Any questions about the theory, about the Crossplane as a project and how and why? And if not, let's see if my demo gods are with me today. So, here we are. So I'm gonna show you how I use it as a user of Crossplane. For that, I'm gonna go to our product called Puyo, and I can log in. And after logging in, I can choose one of the 2 cloud regions that we provide. I'm using the Zurich one, which is closer to Luzerne. And here I can create a new namespace, so Aarno-Luzerne, to play around with, right? And then I can clean it up after the demo, right? So here I'm using OpenShift under the hood, but it's a project. It's the same as saying as Kubernetes namespace. And within the namespace, I can do stuff, right? I can add stuff. So here I want to deploy, and actually I'm going to use the minimal example that I had on the slide, literally, just to show you that that's actually possible, right? So I can order a Postgres database with this minimal example, and I don't have to care about all of the how and different stuff, right? So here you can see it created it. Actually, it, of course, expanded it quite a bit with all the managed fields that I can click here down. But then you can see, okay, it has by default, it has like deletion protection enabled for the backup. It makes 1 instance. Okay, that's enough for me. It's not a high SLA service. It uses version 15, which makes sense for my use case. It uses the standard 2 plan, which is a sizing. And then I see here condition, reconcile success true. So it found it, right? And then it's starting the database now. Type ready is false. And then if I reload, at some point, usually it's about 9 to 15 seconds, container for the Postgres container to start up. It'll go true right here, right? And then, as soon as it's there, we can already have a look at the secret. No, we cannot have a look at the secret until it's actually loaded. So let's give it a sec. Claim is waiting. Available, true. Ta-da! So now I have a Postgres running. Let me go have a look at the Postgres credentials. YAML there again, base 64 encoded. But now I can use this secret for my application, access the database, and do stuff with that. I'm a little bit at the end of the time. I could have shown you that the database is actually running in a pod in a different namespace. I have limited access to the namespace. I can do kubectl get pods. I can do kubectl lots on the database, but that's something for next time. Any questions or inputs?
Maybe.
Sure, absolutely.
What do you see, what is the advantage in using Crossplane instead of Terraform, for example, to provision infrastructure?
Absolutely. So this is, of course, a religious question, right? Which I'm very opinionated about, so thank you for asking it. As a software developer, I write my code. I write the Docker file. How does this code get into a container and what kind of application server and extensions and modules that I need so it's actually runnable. And then I can build it and then I can test the application. And then I define what is the configuration of the application, how it is deployed. And I write that in Kubernetes manifests or Helm charts. I write it directly or indirectly in Kubernetes, right? And that is everything I need to make that into a GitOps pipeline and deploy that onto a Kubernetes cluster so my application is fully runnable. Now I have two options. First, I use the same tooling that I already used to declare my application and the state and how many replicas and I need. And I also use the same tooling to declare that, oh, by the way, I need a database or a reverse proxy or a cache or whatever service that is around it. And I can use the same tooling to deploy the request for a database onto the cluster as I used for my application. Or what's the alternative? I use a second Git repo, put my Terraform in there, make a separate pipeline for the Terraform, which then makes my database and whatever, if it's available through a Terraform API. And then for each deployment of my application in one Git repo, I have to make the other deployment in the other Git repo for the Terraform. And then if I want another deployment of the application, I make another deployment in Terraform. I mean, the problem is it's a different tooling. It's actually the same problem we had 10 years ago when we started the company, is that we had like the application code in one Git repo, and then we managed the virtual infrastructure using tools like Puppet or Ansible or anything, but they never were combined, right? They were never synchronized in the sense of being the same repo or something, being able to actually be used by the developers themselves. And that I feel is one of the problems of Terraform. It's beautiful, it works, it's nice. I don't like terraform.tf, the state file, but that's okay. But it's painful to integrate into your software development process and lifecycle. And that's the same problem that I saw in Puppet and Ansible 10 years ago. So that's why I prefer to put all of it in Git. I have true GitOps for the whole application, including all the dependencies. And for that, I believe Crossplane is an awesome tool to enable that for everything that's not the application, the deployment and in service and ingress and whatever, for everything that's outside of my application, for example, database. Perfect. With that, thank you very much. Have a short break and see you in 4.5 minutes.
I have to speak quickly.